Okay, sorry about that. My video just kind of cut out on me. So, what elements did you think were similar to sodium? Hopefully you answered all the elements in group 1 because sodium is in group 1. So if I look at my periodic table, sodium's right here. Okay? So, hydrogen's kind of an odd duck though because it's a gas. So we really should just be lithium on down. So lithium, potassium, rubidium, cesium, and francium will be similar to sodium. So lithium, potassium, rubidium, cesium, and francium. Okay? What elements are similar to fluorine? Hopefully you answered things in group 17 because fluorine is in group 17. So you should have answered things chlorine, bromine, iodine, and atastasine. Okay, so let's go back to that. So things that are similar to fluorine, you should have chlorine, bromine, iodine, and atastasine. Okay, it looks like it did not save my stuff as I flipped back and forth. Okay, so give the family name for group 1 metals. Now this is kind of a review. If you remember back on our periodic table that we did a couple of days ago, the family name for the group 1 metals are the alkali metals. Okay, let's get rid of this francium here. That's not what we want. Okay, so we want the alkali metals. Okay, remember they are called the alkali metals because when you put them in water, they create a base. And in British English, alkali means base. Give the family name for group 2. Go back and look at your periodic table that we colored up. Group 2, if you remember, is called the alkaline earth metals. Okay. Next, we want the name for group 17. So group 17, fluorine, chlorine, bromine, iodine, those are the halogens. And the family group for group 18, if you remember, these are the noble gases. And remember, we name them the noble gases because they do not interact with anything else. They don't interact, period. So they're kind of like nobility. They keep themselves separate. Okay? So we've been working with a very simplified view of the electron shells, being in the Bohr model, sometimes called the planetary model. Because doesn't this look like the nucleus is like the sun, and these are the orbits of the planet, of the planets? So a lot of times people will call the Bohr model the planetary model. Okay? Remember on this first level, energy level, we can put 2 electrons. And then from here on out, we can put 8 electrons on the next levels. Okay? Remember the octet rule? We talked about the octet rule a while ago. Now the octet rule, remember we said that atoms will lose or gain electrons in order to form an octet. Atoms will react in order to obtain an octet, meaning 8 valence electrons in their valence shell. Okay? And by react, I mean they will react in ways that some will gain electrons to get that octet. Some will actually lose electrons to get that outer valence layer off so that they go to an inner valence layer that is 8 electrons. Okay? So when we react, we will either gain electrons or lose electrons. Now, the atoms that tend to gain electrons are our nonmetals. And if I gain electrons, I will create a negative ion. And the atoms that tend to lose electrons to achieve that octet are our metals. And if I lose electrons, remember electrons are negative, so if I get rid of the negatives, I end up having a positive charge. Okay? That will be really handy in a few. Okay, so the electron shell of carbon is going to be like this. We've got 4 valence electrons, right? 1, 2, 3, 4. It doesn't have an octet. But if I look at neon, neon has 10 electrons and 10 protons. So if I look at neon, I will have 10 protons in the center. That first ring, I have 2 electrons. And that second ring, I will have 8. I will have an octet. Notice all the noble gases, they have octets. The only exception for that is helium. And the reason that the noble gases have octets, and we call them noble gases, is because they don't react. There's something super, super stable about an octet. Okay? So we're trying to always get octets. So if we look at chlorine, we will have, let's see, I'm just going to do chlorine. We've got 2 electrons in the first shell. We've got 8 in the second shell. And then we've got a third shell for chlorine, but we've got 7. So we're missing 1 electron shy of an octet. All right. So if I pattern this, I will have 2 in the inner shell, 8, and 7. All right. Place the following element pairs based on their properties. So we're going to look at valence electrons. Which ones have the same valence electrons? So let's look at sodium first. Is there anything else in there that has just 1 valence electron like sodium? Potassium does. So we're going to pair those 2 up. Okay, take a minute and pair them up. Okay, let's see, argon. Argon has 8. What else has 8? What else is in that noble gas? Ooh, radon is. So radon and argon are a pair. Let's look at calcium. Calcium has 2. So what else is in that column with calcium? Magnesium is. So calcium and magnesium are a pair. Our next thing, chlorine. Chlorine has 7. What else has 7? Ooh, iodine does. So calcium and iodine are a pair. And then last but not least, we have sulfur and oxygen, and they each have 6 valence electrons. So we've been able to pair it up. Okay? Explain why strontium. Strontium, remember, is in that second column. Why do you think if you ate strontium, or ingested strontium is the fancy word to say if you eat it or get it into your body, Why do you think it would accumulate in your bones? What are your bones made out of? Think about that for a second. Aren't our bones made out of calcium? And isn't calcium also in the second column? Didn't I say that everything in the same column would have very similar properties, both chemically and physically? So if calcium is what makes up our bones, do you think strontium would be able to replace calcium in our bones because it also is in the second column? It would be. And we can actually use strontium to trace a lot of nuclear exposure in people's bones if they've been in nuclear fallout areas, because that will pick up into their bones. All right. Have a great day. We'll talk to you later. Bye.